Hey class, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, he's having me talk to you guys about Chapter 2-1, Inductive Reasoning and Conjecture. It's a pretty quick lesson, so make sure you guys paying attention. A lot of different vocabs here, okay? So let's start. Inductive Reasoning. Okay, basically inductive reasoning is using evidence. That's that, using evidence, and then over here to make a statement. Okay, that's what this lesson's about. Okay, using reasoning, using evidence to make a conjecture. And a conjecture is basically a statement, a hypothesis, like those things, okay? Let's put it here too. Hypothesis. Okay. So you've been doing this throughout your math career. Looking at example 1, write a conjecture about the next number in the sequence. You have the sequence. The answer is already here for you, but it's really just showing you, just want to break it down. This part right here, this red part is your inductive reasoning. Inductive reasoning. Sorry, it's hard to read. Inductive reasoning, which would lead to your conjecture, which is your next statement, right? Your educated guess. In this case, 3 to the power 5, a little mental math. 343, I think that's right, 343. Nope, 243. Dang it. 243. To the power 5, okay? Oh, it's right here. Nice. Okay, next one. Write a conjecture about the number of small squares in the next figure. 1 squared, there's 4 squared, there's 9. It seems that, if you look here, looking at the pattern, the sides of the squares have measures 1, 2, and 3. And it ends up, you just square them. Alright, so this is actually 1 squared, 2 squared, 3 squared. Next one, 4 squared. Okay, so it would be 16. Okay, easy stuff. Should I have you guys pause here? We'll just do this real quick. Okay, do number 1. Okay, get the pattern. I think we should know this, not too bad. I believe you're timesing it by -2. Okay, times by -2. Right, your goal is to write a conjecture that describes the pattern. In this case, the pattern, your conjecture, this is your conjecture here. Multiply by -2. And then your next step says, use the conjecture to find the next number in the sequence or the next item. In this case, times it by -2 again. -80. Boom, easy. Bam. Okay. Pause the video here. Pause it, hit pause. Pause. Okay. Oh, sure, don't pause it yet. No, don't pause it yet. Do 2 and 3. Okay, do 2 and 3. Now pause it. Okay. Alright. I'm pretending it's unpaused now. So, the next two, real quick, the answers. You're just timesing it by 10. Easy mode, easy mode. Okay. Multiply by 10. Answer, 10,000. Boom. Okay, over here, oh, it looks a little tricky. What's going on here? Oh, you're adding, huh? You see that? You guys are adding? You're adding, what are you adding? 1/5. Okay, the next one is 9/5. Okay, so that's like kind of review. It's like the algebra part, right? We're gonna switch over to geometry here. So write a conjecture about each value or geometric relationship that we see. Okay, so here's the conjecture. Oh, sorry, here's the statement. Angle 1 and angle 2 form a right angle. Okay, so what does that mean here? Angle 1 and angle 2 form a right angle. So there's a couple things you could assume. That would mean angle 1 plus angle 2 is 9 degrees, right? Another true statement. There's also something that starts with a C. Angle 1 and 2 are also complementary. Boom. They're complementary angles. What else can we assume? Angle 1 and angle 2 are acute. Boom. Okay, they're acute angles. And there's one more thing. This one's kind of tricky. They're also starts with an A. A. It means next to. They are also adjacent. Okay. Oh my gosh, what just happened? Okay, they're also adjacent. Right, if you draw this out, right, you draw a right angle here. If you have angle 1 and 2, they have to be next to each other if they form a 90-degree angle. Okay, so they're next to. Alright, let's look at number 6. Angle ABC and angle DBE are vertical angles. Okay, vertical angles. Let's have a visual of that real quick. Right, when in doubt, draw it out. Let's go ABC. Boom. DBE. Okay, so they're vertical angles, which means what? That means the angles are congruent, right? Boom, that's a good conjecture right there. They are congruent. Another thing could be they share the same vertex, right? They share B as their vertex. Is there anything else? I think that's about it. That's about it. Okay, next one. Angle F and angle E, or angle E and angle F, are right angles. Ooh, look at this, okay? Math is very detailed. Those two angles are right angles, while these two angles form right angles, okay? So it would be safe to say that if they're both right angles, angle E and angle F are 90 degrees each. That also means angle E has to be congruent to angle F. Yeah, we agree with that. Angle E is congruent to angle F. Angle E plus angle F should equal 180. Which means what? Which means angle E and angle F are supplementary. Yeah, sorry if I'm going so fast. You can always adjust the speed on the YouTube, right? Listen to it slower or listen to it faster. Right, up to you guys. Boom, that's the first page. Not too bad. Let's flip over to the second page. Okay, so that's a conjecture. Okay, basically you have a statement and you need to draw more from that statement, right? Just from that single statement, you can get more information, and that's what we just did there. Next, okay? So now we have conjectures, we have statements, but now we also have something called counter arguments, okay? So a conjecture is false, okay, so something could be wrong if there is even one situation. You just need one information to make a counter argument in which the conjecture is not true. This false example is called a counter example, okay? All right, so kind of just reading this here. I'll read it out loud, kind of read to yourself. If segment AB, so AB, and is congruent to segment BC, so I put the markings here, boom, boom, then B is the midpoint of AC. Ooh, okay. Is it possible to draw a diagram with AB is congruent to BC such that B is not the midpoint? The diagram will be a counterexample because B is not on AC. Look at this, guys. Okay, look. I kind of gave you guys, or the textbook here gave you guys the answers already. So this is AC, right? Boom. Here, B is the midpoint. Okay. If AB, right, in this case, is true, right? AB is congruent to BC, and this diagram is true, then B is the midpoint. Okay, this would here be true. This here in orange is what we call our counter example. Because now this picture, right, can we still see that AB is congruent to BC? Right, those two are congruent. But is B the midpoint? Right, the B has to be on the same line, but in this case it's not. Right, a more exaggerated case would probably be something like this. I'll make it even more. I'll probably do this. See, look at this. this is A, and this is B, and this is C, I can say AB is congruent to BC with those tick marks. But you see, B is not the midpoint, right? We don't call that the midpoint. Okay, in fact, that's actually a vertex. Okay, so that's why this is a counter example. So let's get some practice here. Determine whether each conjecture is true or false. Give a counter example for any false conjecture. Okay, so if it's true, it's always going to be true. Okay, if it's false, you need to prove it. Why is it false? Right? You need to have at least one counter example. So let's do number 1 together. We'll do 1 and we'll do 1 and 2 together. If points A, B, and C are collinear, okay, remember collinear means same line, then AB plus BC equals AC. Okay, let's kind of do this here. Okay, so let me just do this. ABC, boom, they're collinear. Okay, they're on the same. Actually, I'll make it here. Boom. Dang it. ABC. So would this be true? Would AB plus BC equals AC? That's true, right? Seems to be true so far, but can I not do this? Check this out. A, ooh, boom, C. Can I not do that? Right? So this is a valid drawing where C is just, somewhere in the middle between A and B. So in this case, would this be true? AB plus BC equals AC? Is that true? The answer is hell no, it's not. Okay, that wouldn't make sense, right? Because AB is a big chunk. AB is a big chunk, and then you add BC to that big chunk. It can't equal something smaller, right? That doesn't make sense. So this is your counter example here. Boom. So it's false. This is your counter. Boom. All right, next one here. If angle R and angle S are supplementary. Okay, I'm going to write this out first. This one's kind of tricky. If angle R and angle S are supplementary, right, when you get like all these vocabs, just break it down. Angle R plus angle S equals what? It should equal 180. Okay, 180. And then angle R and angle T are supplementary, so that's also going to be 180. Okay, so those two are valid. Then what happens here? Angle T and angle S are congruent. Is that true? Looking here, look here, angle S and T. Are they going to be congruent, right? One, you can test it out real quick. Oh, what the heck happened? You can test it out by just plug a random number for angle R. Let's just pretend angle R equals 10. If angle R equals 10, what does angle S have to be? 170. Which would then mean angle T also has to be 170. Okay? So is there really going to be a scenario where angle S and T won't be congruent? The answer is no. They're always going to be congruent. So if they're always congruent, you put true. And to kind of prove this algebraically, what you would set up is just saying angle S is equal to 180 minus angle R. And angle T is equal to 180 minus angle R. So then you can see that both of them are the same. Thus, angle S and T are congruent. So that's why, again, this is true. Whoa, I can change my I can make it blue. That's new. Whoa. You guys like green? No, it's Edison. I'll give it red. Red is pretty cool. I'm going to switch to blue. It's no different. Alright, hit pause. Hit pause. And I'm going to show you guys 3 and 4 just a bit, okay? So do 3 and 4 on your own. Please hit pause right now. And we'll be back. Okay, we're back. And you find a better way how to do that. So anywho, 3 is false. Okay guys, 3 is false. Angle ABC and DEF. So they could be supplementary, right? They're supplementary. Then AB, C, and angle DEF are a linear pair. So here's a little difference, okay? Linear pair means that they're connected. It has to form a line, right? Linear pair has to form a line. Whereas supplementary, it just has to add to 180. So here's your counterexample here. Could you not just have two angles that are separate? Like one's from like Utah, one's from like Kentucky, right? And this is 110 and this is 70. They don't have to be connected. So the fact that they're not connected, it is not a linear pair. So that's why that is your counterexample, okay? So not all supplementary angles are linear pairs, okay? Some are, right? Like, are these angles supplementary if I do 70 and 110? If I do like this, then yes, there's supplementary and it's a linear pair. But in this case here, it is just a supplementary pair, supplementary angle, okay? All right, number 4, it's gonna be true, okay, if the lines are perpendicular. No matter how you draw it, you can draw it any way you want. If you draw perpendicular lines, DE and EF, DEF will always be a right angle, okay, no matter how you draw it. Cool. I guess that is it for this. Please make sure you guys do your homework. It's gonna be due Thursday. If you guys haven't taken that quiz yet, make sure you take the quiz by Friday midnight, right? Friday midnight or 11:59 p.m. Okay, check Canvas for more information on that quiz. Okay, it's on Canvas, right? Check the show your work part. Okay, it's on Canvas. This is more optional practice. If you guys want to do it, it's optional. The key's on Canvas as well. All right. All right, guys. Have a good day. Okay. Tell Mr. Wynn I said hi.